Hi everyone, welcome to our second part in our series regarding the HV BSL range of battery products. With me today is Andre Harrison. He is our technical manager for all our products, specifically focusing on our battery technology on both LV and HV technologies. As you can see behind me, we have the full BSL HV stack, 10 complete modules making a 77 kilowatt. Andre will be taking us through a technical deep dive in this video, and he'll be discussing with us the most relevant technical points on this battery that you need to know as an installer, making sure that you put in the right product for your customers. Andre, tell us more about this battery.
Okay, this is very exciting. As an ex-installer, we know where the problems are in terms of installing a battery like this. It wasn't designed by myself, it's actually designed by Scott. The whole idea behind this topology of the battery is that you can choose the nominal volt you require. From anything up from 150 volts right up to 950 volts, we can cater for all inverters. As you can see, this is stacked at 10 high with the BCU on top, which is basically the master BMS. And you put the battery in series to obtain the correct voltage you want. So we've got one typically set up for a SunSync, which is 10 modules. We can go more in depth in details on how we connect it and how it works. What does it come with? Why we went with this topology, as you already know. Also has a base with wheels on, so you can move it around nice and easy. And you've got little bumpers on the base, you can screw out the bumpers and you can make it more stable.
We are actually at this point in time running this exact battery to power our building. Am I right on that? Right? And so far, the results are astounding. We will cut to those aspects and we will have another video covering the cloud-based monitoring system for this battery. Andre, in terms of this battery, our first video, we did mention that it's a 7.7 kilowatt module, each module, with built-in fire suppression.
Correct. About 7.8, just shy of 7.8 kilowatt hours per block. Nominal volt of about 58 volts, if I remember correctly. There are 18 cells in the block, and then obviously you series them as you require the desired voltage. So the BMS is very clever. The BCU unit, this unit on top, it determines what's the pack voltage and also determines how many cells there are. There's quite clever learn algorithm as well in terms of finding out what size battery is and adapts to the correct voltage and pack.
So let's just unpack one module quickly. What is in one module?
Because so typically in one block over here, you're going to have 18 cells. You're going to have a connection point, positive and negative. And if you measure on there, you're going to get about 57 volts if you get your finger into it. And then it's got your communication board with a built-in BMU, which you can access from the front. So you don't have to take the battery apart. You remove this front cover, you get to the BMU unit, and the BMU just controls the cell voltage, gives data to the BCU unit on top, as well as the temperature. And it does limited, what we call passive balancing.
Tell us a bit more about why that's important.
Easy to service in the field. You might just need to change a BMU unit. And what you can also do, you can actually say there's a faulty BMU unit on that particular module. You can actually take it out of the series pack and you can run it with typically a little lower nominal volt, but your system in most cases should still work. So we're trying to also cater for if there's a problem in the field that we can actually make a plan, like we say in the industry, and then the unit can come in, you can still carry on, or we can actually just change the unit out in the field without having to bring the battery in.
Okay, fantastic. So quite a lot of high voltage batteries though do not have 18 cell design. What makes 18 cell something, number one, why we chose it, and number two, why is 18 cell important?
Okay, so you want to try and get the nominal volts. A typical 16 cell, if you put them in series like you do, you're going to get about 55 odd volts. So the capacity allows us to put extra 2 cells, so we're trying to utilize on less blocks and rather have it spread out more. So 18 cell definitely is a better option when it comes to trying to get the nominal volt. Also, make it very clear this cannot be used on a 48 volt system or a 51 volt system like we refer to in the industry. So that also helps us determinant in terms of where the battery can be used and only be used. So it helps us.
Thanks for that, Andre. Just wanted to touch quickly, what are the depths of discharge that we're talking about here? What are the cycles in terms of that?
Talking about 6,000 cycles to a depth of discharge of about 80%. In other words, 20% stated charge remaining, 80% DOD, 6,000 cycles. But I would just like to make sure people are aware that 6,000 cycles doesn't mean that you're still going to have 100% capacity of your battery remaining. It means that there'll be X amount, preferably above 75% of your remaining capacity after 6,000 cycles or 10 years, whichever comes first.
And our warranty is a 10-year warranty.
10-year warranty or 6,000 cycles, whichever comes first. So if you're cycling it 4 times a day, you will not get your 10 years. If you're cycling half a cycle a day, pro rata, so 2 days is 1 cycle, you definitely need your 10 years, whichever comes first.
So quite interestingly enough, most other competitors, and I won't name names of course, but most other competitors don't give you a 10-year warranty on a high voltage battery stack, am I right? Most of them don't. So, you know, there's a lot that I've come into contact with over the last 5 years. Performance, 1C.
Yes.
Why is that important?
So most lithium cells should be able to give a 1C, that's controlled by the BMS. Our batteries are 1C, in other words we can give 135 amps times the nominal volt. That's quite a lot of power. So if you've got 500 volts times 135, that's quite a lot of power. There's a lot of wattage you can pull out of these batteries.
And with your analysis, where can we comfortably stack these batteries up to in terms of kilowatts? We did mention in the previous video between 300 to 400 kilowatts.
Yes.
Is that a comfortable assumption that we can work with on this?
Yes, you can, obviously depending on the inverter. So just to go back to this particular setup, you can put 16 batteries in series. So if you take 16 times the kilowatt of the battery, you can parallel through the CAN protocol, you can parallel up to 5 stacks like this. So if you work it out, depending on the size of the inverter, that's the maximum you can pull out of this type of setup, which is a lot of power.
It is a lot of power. All right, Andre, thanks. Can you give us a run through on the design a little bit more in detail for us?
Okay, so we decided not to go with the typical rack mount system. This bolts or sits on top of each other. I'm going to turn the battery sideways. It's got little pins on each battery. It's got a little clip system. So the advantage of that is if you have a height problem, I can split this into 2 with a parallel with a connection kit. Also, while we've got it on the side, you can see this is where the Wi-Fi dongle sits. So that's not encased in the casing. You can get better reception because it's outside, and they've got little clips. Very easy to install. Line up the 4 pins, and you lock these little clips on the side. So basically, the idea behind this is that 2 people, if you're ready with a bit of effort, 2 people can assemble this battery. So you can assemble up to potentially 400 plus kilowatt hours just using 2 people. Alright, so we're going to go more to the features on the front of the battery. They come with all the cables. You'll see that the BCU unit on top has 2 additional connection points. They are not the same as the cables that fit between the actual batteries themselves and the BCU unit. And when you put them into series, they come already supplied. I'm going to show you that it's a 4-meter cable, it's a silicon cable. There's double connection points for typically like the SunSync. It needs 2 connection points to get the full power out of the inverter. We supply it already. The new ones will not come with a lug on the end. You can cut the cable to the length you want and you put your own lug on, or the lug we supply, but this one's already been pre-made. It also comes with a communication cable. It's nice and long, it's about 5 meters and very simple to connect. You can't really make a mistake. Your top cable is a red to red, back to back. I always say to the people, start with the top, start with your red to red, and then it's black to red, black to red, black to red. And on the last battery, I was going to remove the cover. The last battery is left with a black connection point. And whether it comes, the set comes with a battery, a long cable that you can connect all the way from the top to the BC unit to the last battery. Very easy, very simple. It's got standard CAN protocol, so the PCS talks to the inverter, directed to the inverter. So typically a sunset, it goes straight to the BMS 1 port or BMS 2 port, depending how you configure it. And then your common will be to the next battery, and the last battery will be the terminator. Very simple, very easy. Take you a couple of minutes to figure it out. And then of course your communication cable, as I said just before, if you start on the top, you can't really make a mistake. It's out to in, out to in, out to in, to the last battery. Very easy, very simple. Okay, so now this is a completed assembled battery. When you've done the cable connections, you now want to get an extra feature, you can cover it. All the batteries, all the modules come with a cover like this. Very simple, 4 little clips, adds to protection and also stitches. So there we go, I've got a couple of more to install. Last one. Done. Okay, as you can see, it's already been assembled. My 2 connection cables are already connected, 2 for positive, 2 for negative. For a sunset, you do not have to use both. You can use one. You'll get a maximum of 100 amps per connection point. It's a 1C battery, but you have 100 amps per connection. If you need more than 100 amps, we advise you to use both cables. Right, very simple procedure. Already connected to the inverter. My communication cable is already in. The start procedure is first put on the oscillator. Okay, I'm going to put it on now, and I'm going to switch it on. That's as easy as that. It'll take a while, it'll fire up. You'll see the voltage, the screen will light up, it'll tell you the percentage. It will now do a self check, and then after about 15 seconds, it'll charge up the caps for 6 seconds, and then switch on the inverter. So you can supply the power to these 2 points here. We'll go through the screen settings now once it's fired up. Once it's done its pre-checks, once it's pre-charged the system, then everything is normalized. We'll go through the settings. Alright, so this is now stabilized. The battery is on, the inverter should be on as well. Quick rundown of the telemetry. It's going to give me what am I charging or discharging in amps. It's going to give me the nominal volt of pack, which is in this case is 600 volts. It's also giving me a percentage, as well as the average temperature between all the temperature probes in every single battery block. So, now a couple of nice features. If I touch the screen, I can change the color by pushing the arrow to the right. That's now changed. It's now light gray. However, just be cautious. The temperature reading that is in red, it's not a warning, just telling you that's actually what the temperature is. So most people prefer the darker setup because some people are not happy with the fact that the little bars are in red. In most cases, red means a warning. However, in that screen over there, it just tells you its temperature. If there's a warning, the battery light will come up, and when it's charging and discharging, the little AC kind of extension will also come up and flash. So that's nothing to worry about, that's normal. So I'm going to change the screen back. As you can see, that's the most common screen that the guys like. Also has time, that will synchronize once you connect to the Wi-Fi, once you set up the Wi-Fi. So I'm going to touch the screen. You can change how bright you want it. Oops. If I click on there, I can bring it up or brighter. There's also a little spanner. There's a little spanner and a screwdriver. If I click on that, it gives me a lot more telemetry. The most common one will probably be cell voltage. I can go and look at each pack cell voltage. So if you look at that first pack there, it's 1 to 6, 7 to 12, etc. all the way to 18. In other words, that's the first block you're looking at, which is the top one. All the way down, last one being the bottom. So I'm going to go through all the cells, have a look at the cells. We're going to do all that now, and I'm going to look at the temperature as well. All on display, we'll exit that. As well as I've got some general information. It's telling me there is a couple of red lights there. That's because it hasn't seen the inverter, it hasn't started charging, that's normal. And it also tells you if there's a problem, it'll come up on the fault page. And right now there's no faults, so this battery is ready to go. Alright, and once again, just to recap, there are sales technical staff available to help you, as well as a technical department in any queries. We do offer training once a month, third week of the month. We'll need to book for that. We also appreciate any feedback, so we take feedback quite seriously. And then once again, thank you that you're looking at BSL as a product and you're interested in the product, and thank you for watching the video.